In today's lab, we are going to determine the multiple proportions of copper oxide. So the reaction that's going to take place, the copper oxide will react with methane and produce water vapor, carbon dioxide, and solid copper. Our method is going to be by reacting the copper oxide sample in a test tube. This test tube will be hooked up to a gas line source, so natural gas, methane gas. Be fed through the tube. It will react with the copper, which is over a Bunsen burner. The heat will help the reaction happen. And as the reaction happens, the carbon dioxide and water vapor will leave through this top tube here. Now this tube here is going to be lit. This is going to be our pilot light. And so the excess methane is going to be burned off, and that's why we're going to light it, because we don't want the room filling with methane gas. Whatever initial mass of copper oxide you have at the beginning, as we continue to heat it, it's going to lose mass as the oxygen is removed from the compound. This is going to result in just copper. So whatever mass of copper that remains, you're going to calculate the moles of copper, and you're going to determine the difference between these two as grams of oxygen. You can calculate the moles, and we'll be able to determine the formula. Now there's two different samples. There's either the red sample or the black sample, and of course we expect that their masses of oxygen loss are going to be different for each of them. So we'll have data for both values, and you'll be able to calculate the different formulas that arise. So first we're going to weigh an empty test tube, and this is going to be for our red sample. Notice that I've used a weighing boat with the corners notched so that the test tube doesn't roll off the balance. There's a little bit of a draft in this part of the lab, so we're going to have to do our best. We're going to call the mass 57.981. So I've added a sample of the red copper oxide, and now I'm going to weigh it. We're going to call it 63.981. Next, we're going to weigh the test tube for the second sample. Same method. And this one we're going to call 58.110. Now we're going to weigh our black sample. And it's looks like 63.876. Okay, so I've got the red sample set up. As you can see, I have the red sample under the direct heat of the Bunsen burner. You can actually see it changing color right away. The test tube is connected to a second gas line, and the methane is going into the test tube. It's reacting with the oxygen that's in the copper oxide, and it's being converted to water vapor and carbon dioxide, which is exiting through the top. And the reason why the top is burning is because the excess methane that's not reacting is, well, it's not reacting with the copper, but the excess methane is being burned off. I went ahead and I lit it with a match. So this is to make sure that the excess methane doesn't fill the room and potentially build up. You can actually see that the red copper is turning to blue, or sorry, black. And this reaction is going to take a while, so we're going to come back and visit it later. This is the apparatus for the black sample, and of course it's starting as black, as you can see. And I have it set up the exact same way as the red sample, with the methane traveling in through the hose into the test tube, reacting with the copper oxide. carbon dioxide, water vapor leaving, as well as the excess methane leaving. So I've got both of these running simultaneously. There's the black, there's the red. Well, red is black now, but it started as red. And we're gonna let these guys run. We're about 20 minutes in, and this was originally the red sample. And if I pull the heat away, you can see that there's been a color change. It went from red to black, and now you're seeing that reddish copper color. We'll go over to the black sample. We've got a little bit of a color change as well. Getting some of that copper color as well. And if you look closely to the tubes, we see some water vapor forming. So now we're going to weigh the final mass for the red sample. 63.30 63.297. We'll just go with that. 63.297. Solid is a orange reddish copper, much like how a new penny would look, just not as shiny. Next, we're going to weigh the second sample, which was originally the black sample. $62.727. And it has an identical appearance to the first sample.